My name is Nielsen, and I'm a senior psychologist at the National Research Center for the Working Environment. I want to talk to you about the importance of securing a sufficient statistical power before performing a statistical hypothesis test, and discuss how a failure to do so can bias the research literature. Consider the following situation. We have distributed a questionnaire to a representative sample of a given population. From the questionnaire we have, among a lot of other things, information about height and monthly pay. We hypothesize that women who are taller than 170 are better paid than women that are shorter than 160. And we want to estimate the difference in the average monthly pay between these two groups. The estimation and the hypothesis testing will take place simultaneously. If the lower boundary of a 95% confidence interval is greater than 0, then we accept the hypothesis. Before performing the test, we calculate the power. Let's say we believe that the true difference is 1,000 kroner per month, and that our calculations show that the power of finding such a difference in our material is 0.2. Since there is a one-to-one relationship between the power of the test and the width of its associated confidence interval, we can also determine if the estimate is what we expect it to be. Then the estimated 95% confidence interval would go from minus 750 to plus 2,750. It is clear to us that this interval is so wide that the estimate would be considered meaningless, and we wouldn't be able to publish this result. We now have two choices. Either we test the hypothesis, or we choose not to test the hypothesis. We can also reason that we most probably would be able to publish the result if the difference was significant, and choose the following strategy: we test the hypothesis. If the difference is statistically high, then we can submit it for publication, and if not, we pretend we never tested the hypothesis. This is, however, a seriously biased estimation strategy. If the power of the test was 20% and the true income difference was 1,000 kroner, then the least possible significantly high estimate of income would be 1,750. We would, in other words, only be able to publish the results if the estimated difference was at least 75% higher than the true difference. This is a graph which exemplifies the publication bias that will arise from the strategy to publish only if significantly high, as a function of the power of the test. The upper line gives the expected estimate if significantly high, while the lower line presents a true value. The gap between the two lines indicates the publication bias, and as you can see, the lower the power, the greater the bias. The graph shows that in our example, where the power was 0.2 and the true income difference was 1,000 kroner, the expected income difference, given that it is significantly high, is about 2,200 kroner, which is more than twice the size than the true one. This is something one should be aware of, not only as a researcher, but also as a reader of research literature. When we encounter a statistically significant estimate, we have to ask ourselves if that estimate would have been published if it wasn't statistically significant. It is also important to be aware of this mechanism when we formulate inclusion criteria for meta-analysis. It is surely a great criticism of our profession that we do not refrain from performing statistical hypothesis testing when it is so underpowered that our outcomes only can be published if they are positive.